Hello guys, in this video I'm going to show you how to solve longest substring with k distinct characters. Given a string, find the length of the longest substring in it with no more than k distinct characters. So, example, given this input string cbb eb I k is equal to 3, it should output 5. The explanation is the longest substring with no more than 3 distinct characters are here CBB first 5 characters. As you can see, this substring has a length of 5, but B is repeated 3 times, so we have total of 3 distinct characters, right? So it's certified no more than 3 distinct characters, right? If we add I to this substring, it's not gonna work out because we will have 4 distinct characters. So here the best answer. Another answer that might have the same result is BBE. The last 5 characters, same here. B is repeated 3 times, right? So for these kind of problems where you have to find contiguous a string, actually string we can consider as just array of characters, right? So problems in which we have to find a substring or subarray that the subarray must satisfy a constraints, like can be anything like different characters or sum of the total of the subarray or the average. So whatever the constraint is, so again, for problems that you need to find subarray or substring with certain constraints, think of sliding window, right? So that we will we save our computations by sliding the window, right, in a certain way to toward our requirements, right? So in this case, let's try to experiment a little bit. Right. So for a sliding window, I want to have two pointer, right? Limit the size, limit the outcome window. Right? Initially, it's both point to the first character. Right? So at any given point in time, we must calculate the number of distinct characters, which is to check if it satisfies the constraint here, no more than distinct characters. So I'm gonna save the current distinct case, right? So current distinct case initially is 0, right? Okay, so our window, let's say we start from here. So our window now is has no distinct characters, right? Has no characters, so it has no distinct character. So we also need to the longest. We want to set the longest as well. Longest sign of the substrings that satisfy this requirement. The current longest, right? So after we iterate to the whole string, we'll have this one, we'll return this one. So longest usually is 0, right? So we start at C. Okay. So now the number of current distinct characters is 1, right? We have 1 C. So current distinct characters is 1, and so here is a certified window, right? It has no more than 3 distinct characters. So we update the longest size to 1, right? We will update this one as long as the current window satisfies the constraints and is greater than the current longest, right? We only want to update if the current size window is greater than the current longest. Okay. So this is a certified window, but probably it's not. Maybe it's not the best one. So in order to find a better one, we might want to expand the window. So use the right pointer, the window end, the window start. Window end pointer expand it to the right one step. So we have CB now. So current distinct character now is 2, but you might realize that we must have a way to check down, to keep track of all the characters of the current window, right? And its frequency also. For example, here C is 1, B is 1. But if we move here, current distinct characters is still 3, right? There's only 2. So from here to here, we must have a way to remember that we have already 1B in the previous window, right? So one way to keep track of character and its frequency is to use a map. In JavaScript, we can use an object to as a map, right? So at each step here, C is 1, here we expand the window, so we add a new one, B is 1, okay, expand the window, okay. Now we don't add new elements, but we update the existing character, which is B, to 2, okay. Now current distinct characters is still 3, right? Still 2. Actually, current distinct characters is actually the total keys in our map, right? Let's call it char map. So here we have 2 keys. It means we have 2 distinct characters, right? So okay, this window is satisfies the constraint, no more than 3 distinct characters. We have 2 here, which is good. So do we want to update the longest side? Yes, because the current window size is 3, which is a better side than 2, right? So we update longest side to 3. Okay. So maybe it's not better, it's not the best answer, so we expand the window to check the new window. So here we update one more key. As you can see now, we have 3 keys, which is we have 3 distinct characters in our current window of size 4. Right? 3 distinct characters. We update the longest side to 4, which is a window size. Okay. Oh no. Okay, we expand again. One step forward. Here we update the latest one, B. We update B, frequency of B to 3. So current distinct characters is still 3, but the window size is now 5, which is better than existing, so we update to 5. Okay, so current window might not be the best one, so we experiment by expand the window to the right. So now I is the rightmost character, so I isn't exceeded in our current map camera. So we add I with 1 frequency of 1. Okay. So now our current distinct character is 4, which is greater than 3, right? So this is not a valid window. So we don't want to consider update the longest side, right? So here is not a valid one. So now here is not valid one because the distinct characters is greater than our limit, right? Maximum limit. So in order to in order to improve this window, in order to improve the current window, we must shrink down the current window to the left, right here. So now by shrink down here, we remove C. Actually, we not remove C, but we decrement the frequency of C by 1, right? But actually currently C has frequency of 1, so it becomes 0, right? So we probably don't want to keep one with 0 frequency because it will affect because we're calculating the distinct characters by counting the number of keys, right? So this will affect our purpose. So when a key's frequency reaches 0, we want to remove it out from the camera. Okay, so now we have 3 keys in here. Distinct character is 3. Okay, longest sign here is a valid window. We want to update the longest sign? No, because this window sign is not better than the longest. It's equal, so we don't want to update. So here's a valid window. In order to make it better, we again expand it. But as we expand to the right, it runs out of the array limit, right? So we just exit our loop, right? So that's it for the algorithm. Let's try to code it out. So as you can see, we need a care maps, right? We need to add element to the care map. We need to remove element to the care map. We need count the distinct characters in the care map. So how about we abstract the logic of care map into a class named care map, right? We need to keep a map inside here. Let's call it frequency. It is a object, right? So we have add character, we have remove character, okay, we have get distinct right, and what else? Okay, for add character, if we don't have the character in the frequency map yet, then we're gonna initialize it value to 0. Okay, then increment it by 1. For removing character, So we only want to, we can do a safe checking here if the guy isn't in the frequency, so we just return right away. It comes here, mean it is in the frequency map, right? So we want to update the frequency of that character -1, right? Then if, as we discussed earlier, if this one reaches 0, then gonna just remove it from the remove this character from the frequency map. Here's how we do it in JavaScript. Get the string guy just simply by count the number of keys in our map. So we return object dot key. This one will return a array of keys, right? This dot of objects, right? So we count the size of the get the size of the array, means we have the, then we return it as a distinct characters, right? Okay, so that's it for this one. Now here's our logics. Wanna slide a window. So window should have 2 pointers. Window start, right? Which is 0, right? So window end, we start expanding it. Initially, we want to expand it, right? 4. But before that, okay, for that, window end equal to 0. Window end, that then string the length. Window end plus plus. Here is kind of template that we want to use for every problem in this category slide window. Window start, window end start from 0. Iterate to the end. Right. So as we discussed earlier, we need current distinct and longest. Current distinct is actually we can get from here, from our CAMAP. So we need to initialize the current CAMAP, right? Const CAMAP in new CAMAP. Okay. So we need the longest side also. That's longest equal to 0 initially, and finally when we exit the loop, we will return the longest. Okay. So at each every time we expand a window at the beginning of this loop is when we expand a window to the right, one step. So as we're expanding, we want to add that that rightmost character to our CAMAP, right? CAMAP add string at that's not sure. String equal to abc string can go at 1. Okay. Oh no. Not calculate, but what is that? Get characters. Okay, add one for example. Okay, string character at window end, right? The rightmost characters we add to the camera. Okay, so now as we adding a new numbers to our camera here, as you can see, the new character makes our uh, make makes our window invalid, right? It because it may increase the distinct character greater than k, right? So here we adding new one, we want to make sure that you may think that we can do something like we can update here, right? Let's say let the window size, we calculate the window size equal to window end minus window start plus 1, right? This one will get the window size. So you may think of like if the camera dot get distinct characters is less than or equal to k, gonna and the is less than k, and we're gonna update our windows, our longest, right? So longest of current longest with the current window size, right? So window size, we check the distinct characters current window size. If it satisfies the requirement, we may want to update only if it's greater than the longest, current longest, right? So now so okay, we try to update if it is certified, and we want to shrink down our window, right? If it doesn't satisfy the requirement before jumping into the next iterations where we expand the window here. So as long as the camera get distinct characters is greater than k, we want to remove the leftmost character from our map, right? Camera dot remove the leftmost, which is character at Windows start. Then we we do this sliding by increase window start by 1. Okay, this is good, I think, but one way to improve it is to, as you can see, we're doing two kind of check here. We check distinct characters with K, right? So one way to simplify it is to just move this one over here, right? So as we're expanding the window, it may make our window invalid, so we make it valid again by this logics. So when it exits the loop here, it means it's valid here. The current one is valid. The current distinct characters is now greater than or equal to K, so we don't need to check it here. We skip checking and just update the longest if the current window size is greater than the current longest. Okay, so we exit the loop. When window n is out of range, return the longest. Just so I'll run the test here. Number 1, 4. Okay. Okay, it works. So that's it for longest substring with K distinct characters. So thanks for watching. See you in the next video.